screen. Oh, interesting. Okay. Um, change mix selection. Um, window screen. Yep, mix selection. Share all application windows. Okay. So if I just double checking that people can see my screen, is that all good? I think that's good. Right. So the idea here is to transform an agent from fragile to production with Aura, and the way we do. So hi, I'm Isa. One of the founders here at Orra. We're trying to make agents work in production. Well, we're making agents work in production, and we have a platform that helps you do this, and it should be easy to install and run. And this workshop is going to work through how we do this. And just a quick brief look at the architecture of Aura itself. The idea is that Aura plugs into, well, it sits between your application and any agents or services or your current existing stack that are running your application. And what that means is that your application can send direct actions to Aura, and Aura can then sort of coordinate them across parts of your application that need to execute those specific tasks. The way we do this is by using things like generating plans, but the plans are pre-evaluated execution plans. We make sure that we have durable execution, and we allow you to go fast by using tools and services. I'll get into that in a minute. And you can obviously revert state, and plans are domain grounded. So we're trying to make Aura handle real world interactions as much as possible so that your agent application can run really well. Let me just check one thing I've got here. Second. So some people are saying they can't see the slides. I'm not sure. Yeah. Oh, okay. No one. How do I switch the window so that I can see the slides?
Down in the
Sure.
bottom left-hand corner, click Screen.
Yep. Screen.
No, bottom left-hand corner.
Yep.
Screen.
But
It's under
sorry,
the
my bad.
Disconnect button. The bottom left-hand corner.
Sorry. Oh gosh. Yep.
Good.
At the bottom left-hand corner.
Yes.
Um.
Of your
Okay.
of
So when
your
you say bottom
stored
left-hand
window.
corner, you mean this bit
It's
here?
middle. That's middle.
Yeah.
You can use
Yep.
that menu too. Change windows.
Okay. Change windows.
We can't see this menu, so I don't know what you see.
Oh yes. I just see like it says add windows. So I guess I can add another window. Or share entire screen is
Your
the
entire
other
screen would be
option.
better.
Yeah, that's
There you
what I
go.
was hoping. Okay. And now can
Yes.
everyone see this screen? These slides? No? Yes?
Yes, we can.
So you can see the slides. All right. Okay, cool. I guess no one was seeing these slides before. Okay, I'll repeat. Um, so this is just a quick overview of Aura. We help you transform agents from or like agent application from fragile to production. And this is more about me. I'll get into that in a second. But essentially, we have a plan engine, and the plan engine sits between the AI application and any parts of your application that require that deal with agents and have to handle complex real world interactions. We have a bunch of features that allow you to do this. The main one is execution plans that run against all your services and agents and any parts of the existing stack. These are pre-evaluated execution plans, so we make sure that they are correct before they run. They have durable execution, so we make sure that any part of your stack that needs to run will continue to run, or we pause the execution plan until it comes back. So we do health checks. We help you refactor your architecture a bit so you can run some tools as services. And I'll showcase how you do that. And then we help you to revert the state if there are any failures or any issues, external issues that the application, the agents can't deal with. You have the availability of compensations that you can use, and everything is domain grounded as much as possible to make sure that if our plan engine doesn't hallucinate and generate plans that are not real. So we'll get to a sample application of what that looks like here. So imagine this is a marketplace AI assistant, and this marketplace AI assistant gets requests from users to execute to buy things or to get delivery or like get advice on some products. So in this use case, you can start with a monolith experience where everything is all in the actual. You have one giant assistant that does everything. So that could look like this. Let me just run one of these. Got it here somewhere. So let me just do it. This went too far. And then go to the agent workshop. So this is such an assistant. It's a marketplace assistant. It's the way it's coded is like it's a monolith. It has a huge chain of function calls, and the function calls get basically executed against an LLM. This gives you a lot of problems like latency, and like the cost per question gets really high. So you can look at the code here for this, for the agent I just showed you, and you'll see that if I jump to function calling, so these are all the available functions to the agent, and the agent has to simultaneously work through every single one of these to understand if it should use it, if it should not use it, and then like place a query against that specific function call, get some results back, deal with those results, look for the next function call. So, and each one of those things, each one of those requests hits an LLM. It's expensive, and it can get quite slow if you start increasing the number of function calls. The way we deal with it, as I alluded to in this diagram, is that you can take some of the function calls are not that do not need reasoning as much. They could be simple services on the side, so you can transform those tools to services. In this case, we have a customer service that tells you information about a customer. This does not really need to live in that stack of function calls. It could be separated out as a tool, as a service. Another one is the inventory service in this case. Just asking questions about what inventory you have does not really need to be part of the function call. It could be separated out. It can be separated from a tool to an actual service as well. And the one here that does actually need reasoning is a delivery agent. So for that, we'll leave it as an agent. But now you see that Marketplace Sales Assistant has been refactored into 3 pieces. We have a customer service, an inventory service, and a delivery agent that can be called in parallel. So you can decrease the latency and increase the throughput of the system, and also as a cool byproduct, like reduce the cost of the interactions with the LLMs. The way we do this is we generate execution plans that will execute against all of these services, but first, you have to refactor these services out of your monolith. So I'll showcase how we do that in Orra. So looking at the example, again, I'll look at some more code. Here is the code that we've got here is in this. So I alluded to 3 different services. So we did refactor all of them out. So starting with the customer service, you can see that essentially, I'll just make this bigger. Sorry, a window. The first thing you have to do is you have to essentially initialize, use the Orra SDK. In this case, it's the JavaScript SDK. And here, In this instance, you register a service, you plug in where the Orra URL is for the plan engine, and your key, your API key, which I'll show you in a second. Once you do that, then you register this service. You tell us exactly what it's about. What does it do? And then you give us the schema of like what inputs and outputs the service requires. So if I come out of that, show you the schema. Wow, I don't know what happened here today. It's just bonkers. Here we go. So the schema is very simple. It's a very here we go. It's an object definition of what inputs to expect and what outputs your service is now going to respond with. And these are useful for our plan engine to understand the capabilities of the service and what it does. The idea here is that you would do this for every part of your system. So you would go to every service that you've now refactored out or factored out and add the inputs and outputs and register with a plan engine. Once you do that, we can generate our execution plans. So here's a sample of the execution plan that I can run. So let's just copy this one, copy that. So imagine this is a chat interface to the marketplace assistant, and a user is asking, "I'm interested in this product, and when can I receive it?" When this gets dispatched to Orra, we analyze this request. We figure out what services based on the capabilities and the registered services that we have for this project. We look at all the data that is available to us, and then we generate an execution plan, and then we execute this execution plan against the customer service, the inventory manager, and the delivery agent, because these are the services that that's already decided are useful to this query. You can track what happens here. So Orra has a CLI. Let me just make that bigger. So in this CLI, you can see that an orchestration just ran about just now. You can inspect this, and you'll see that these are different tasks that were run. A customer service, an inventory manager, and delivery agent. We can go into more detail to understand to figure out what is actually going on here. So you get an audit trail when you put this -d flag, and it shows you exactly what inputs and outputs were received by every service, and which ones were run in parallel and which ones were run directly. So in this case, the customer service doesn't have any dependencies, the inventory manager doesn't have any dependencies, but the delivery agent has multiple dependencies from the customer service and from the inventory manager. And what's going on here is that the delivery service needs to understand, well, the delivery agent needs to understand your home address and your and the product's warehouse address to kind of reason about how to essentially figure out how long a delivery would take, and it uses extra information that is running against an LLM to kind of figure this information out. Any questions so far, or anything? Let's just check the.
There has been one.
Gosh.
It's in the top right-hand corner. It says the number 2, I believe.
Sure, chat. Yep. Let me see. Is this JS only, or do you have other language supported? So it's JavaScript and Python for now. The idea is that our plan engine supports like any language, so that we'll be rolling out more SDKs as we go along. So the next ones are going to be Ruby, and we're looking at .NET as well, because a lot of people in .NET and Ruby world are using agents, and they don't have a lot of machinery available to them yet. And yep, I hope that answers that question. I'm going to showcase like the next some of the other features that we also have. So one of the things that we talked about was reliability. So what happens if one of your agents or services goes down while an orchestration is running? So in our case, Orra essentially pauses things until that service comes back. So any execution that's running, it will just get stopped and then continued. So let's just kill something. So I'm just going to kill the delivery agent. And so it's no longer available. We monitor the health. So if I go back to that UI and run the same query again, and I'll go to the CLI, see it's processing, but if we inspect that, you'll see that the delivery agent is actually paused because it's not healthy. So that's one of the things that Orra gives you. It kind of like understands what's happening to every component in the system. So if I go ahead and bring it back, just run it up again, then just it's still paused because there's like a time window for waiting, and then before the next check. So let's just keep checking. I'm sure it's back. Yeah, it's back. Continue. Right. Come on. It's a longer wait than I kind of expected, but it says it's not healthy. Let me see. Yeah, let's see. It's okay. It's processing again. So it recognizes it's back, and then if I do an inspection, sorry, a detailed inspection, you'll see that it's actually completed. So it was the delivery agent was paused, it started processing, and now it's completed. And again, these are the inputs and outputs that were expected, and this is the final result. So that's one of the cool benefits of having Orra available to you. Another one is that I keep talking about execution plans. So we have execution plans that are run here against all your services, but we are also using LLMs, and so our execution plans could also be slightly flawed. So one of the things that we do about validating these execution plans in the beginning is that we do the if you don't ground the system, we do the bare minimum, and the bare minimum is like to make sure the inputs that were expected are there, the outputs are expected are there. Any services that were expected to be used are actually real services that do exist in the system. So that's like validation 0. But then if we add this concept of grounding, then we make sure that the capabilities that you expect for your application to work against are the ones that are being used. And we also ensure that any execution plans that are generated are like the sequence of events that happens is the correct sequence of events that would happen to change the state from where you are to where the expected results should happen. So like I said, we use this concept called grounding. So I'm just going to show you some grounding. Here's grounding comes. You specify grounding using a YAML file, and it's like a very basic file. In this instance, we have customer support use cases. So we're grounding the system to say, look, we expect our system to really just work for customer support use cases. We do not want anything else. And here's an example of the kind of actions that we're looking for. So we need so inquiries about products when it can be received. These are the kind of capabilities that we're looking for when these sort of actions are fired against Orra. So look up customer details, look up some product details, and then calculate when a product may be received. These are processing refunds for an order. That's another customer support use case that we might look into. So what happens here is that we're creating essentially an embedding space or a latent space around these concepts. So if any action comes in that is similar to these concepts, then it gets executed. If it's not similar to these concepts, then we reject it because we're like, you've just grounded your system towards a single or common use cases that you don't want to diverge from, essentially. And it gives you a bit of predictability, and it makes your agent slightly more predictable, and like makes the system like a bit more robust to kind of achieve the result that actually achieve results there than just generate execution plans that never really execute properly. To apply this, you can essentially apply this grounding against your project. Just Orra grounding, apply CLI grounding.yaml -f. So now we have the grounding is applied. If I go back and execute this again, you'll see that Orra starts reading more about the system, and it does extra checks. Actually, you can see in the logs, but it's not the most beautiful view for now. But as it works through the system, we'll see that it's coming through. There are embedding vectors that are being checked. Okay, so that completed correctly. But if we talk about purchasing items, rather than I'm interested in purchasing this item, this should fail. Purchasing this product. So I want to purchase this product. Please. Football. It's like something went wrong while posting your request. So if I go back to that, let's see what happened. So this failed, and this should fail because there is cannot matching grounding specs against orchestration action. No match use case found. So it's not a support. It's not a support use case. Yeah, it's an actual purchase use case, and we don't execute anything that's not support use case based. So that's what happens with grounding, which is pretty good. So it's almost like a guardrail based system for your multi-agent application. So those are the two use cases. Another use case is that you might have long running processes, and within these compensations essentially. So I'll go back to the long running process in a second. But like so you might have like failures in your system, whereby an error happens, but you need to compensate and roll back and revert a bunch of items that have happened before. So let's simulate one of those errors. Let me check in this bit of the code. I can simulate an error, but it should demo fail. So I can make the deliver agent fail, and that should roll back any inventory holds that have been held by the assistant. So let's put that across. Demo fail true to true. Yep. Okay. So now if I run this again, it should be cached. We'll see this error configured to demonstrate failure. So it should be failed. And then if I do that, See, the deliver agent has failed, so that should kick off compensations. Let's get into detail here. Okay, so it tried multiple times to. So when we have a failure, the system has auto retries, so it tries multiple times to kind of correct this error. And in this case, it retried about 5 times. Because it couldn't retry correctly, it started. It marked as a complete failure. But in this case, the inventory manager was configured to revert, so it kicked off its own compensations. And what that does is removes a hold that was being held. So there was a hold on the inventory, but now the compensation removes that hold. So someone else could essentially order that product. And the way we do this is also very simple. So if I go to essentially, where is it? The customer service, the inventory manager. The inventory manager here has this bit here that explains that this could be reverted, and this is essentially you get back the original task and the result of that task, and you can revert as much as you like. And the state of the world will be changed to whatever it was before. You also mark the service as revertible when you register it as well. Essentially, reverts are really cool. They also have a time to live. So if, for example, if you're dealing with payments and there's a window of like a day after which like something cannot be reverted, even though the payment has gone out, or then that still works. Another thing about revert is like we have a concept of partial revert, so we understand that the system can move on, like the state of the world may have moved on, and that not everything is revertible. So we give you this concept of partial reverts to kind of say, hey, most of this stuff has been reverted, but this one item has not been reverted, and it needs manual intervention by an admin, and that's also visible to you in the audit logs. So that covers that. And I was talking earlier about long-running processes. So Orra gives you this concept of also being able to monitor what's happening between your different processes, using a simple push update. So here, instead of doing all these logs, processing inventory and yada yada, what you can do is you can say, okay, here's a task, and you can push update, and you can add this. Sorry, it's an object. You can add anything into this object. We don't care as long as it makes sense to you. So in this case, let's say it's like progress, analyzing product, or just just a quick message. Just updating inventory product for task. So if I start and stop the inventory manager again, and also I'll start and stop this by removing the so it doesn't fail. Yeah. And just rerun. Oops. Alright, that's because the error UI is not configured for that error. Let me just get. Right, so we're going to run this. It's already cached. So one of the things that Orra does as well is it caches a lot of the any execution plan is cached semantically. So any related actions are you don't have to wait a lot for planning. We don't have to keep hitting LMs for this. So if I go back here and just check about the latest one, so this just finished, you should see some extra logging when we inspect to show you the progress of what happened in the service. So we'll see that the inventory manager, that actually wasn't registered. Okay, my bad. Something wrong with that bit. Essentially, that should have registered here the progress as it's been received from the service. Okay, I think that touches on almost everything. Just check. Right. I'm gonna stop sharing my screen just to understand, see what's going on. Right. Hi. So 2 more questions. Can caching be turned off? So caching is can it be turned off? It cannot be turned off. It's the plan engine caches stuff, but what happens is if there are failures or essentially the cache only respects things that have succeeded. If they haven't succeeded, then they're no longer cached. Right now the only way to turn off caching is by restarting the service. If you restart the service, then that just deletes the cache completely. But obviously that's not a viable thing. I can look into making sure that you have a method of just deleting the cache if that's something that you want to do. But the cache actually clears itself off. So after a specific number of items, it kind of clears. And also, you have a way to configure how long things are cached for. So right now it defaults to a day, but you can change that to less than a day. So that's another way around it as well. And are all LRMs supported? Sorry, I don't understand. Sorry, what are LRMs? What are we talking about? Is that local models or language reasoning models? Is that the question, I guess? Okay, so we use reasoning models essentially. We only use reasoning models effectively. So we use O1 Mini, O3 Mini, or DeepSeek on Grok. Those are the 3 options that you have. LLMs are not supported because of the plans that. So LLMs were initially supported. We ran everything with normal LLMs, but because of the kind of features that we're about to add to the system, we've opted to only use LRMs. The state of the world is changing, though. LRMs and LLMs are becoming hybrids. So pretty soon, I think Claude 3.7 actually mixes the two together. So I think we're going to revisit that decision to to see what does that mean for our system. But some of the new features that are coming up are replanning. So replanning is a bit more complicated, and reasoning models help a bit more, especially if you can see their chain of thought. So that's something that we use with DeepSeek. We kind of like verify the chain of thought between the think tags to make sure that things make sense. So yeah, watch the space. Let's see what happens. So this sort of wraps up like the demo I wanted to give. There was a more there's going to be a better demo. I'm going to be sharing a workshop where we start with in a repo where we start with like a monolith agent assistant, and then getting it refactored to all the different phases. I'm going to put that up in a couple of days, and it's easier to that one's actually easier for self help. There's another question. So does this work 100% locally? No, it does not work 100% locally. You need to use a cloud LLM actually. So that's unfortunate. But we tested it locally, and a lot of the LLMs that we were working against didn't give us really good. The results weren't very good. Or you had to use the bigger open source models, which kind of might not, like a lot of people might not be able to run locally. I guess I'll wait for more questions before I Okay, I think I'm gonna call it a day. Thanks everyone for joining. I hope this was useful, and